everyone. So in this video we're going to talk about general characteristics of acids and bases and ways that you can tell them apart. So one of the first things that you can tell apart from an acid from a base is how they taste. So acids taste sour, whereas bases taste bitter. And you might be wondering why we're tasting acids and bases, because you've been told never to eat anything in chemistry class. However, acids and bases are in everyday common items, and so you sometimes eat acids or bases. Well, acids more so than bases. Acids, the way they feel, is they feel like water. And by that, I just mean that they feel like any regular liquid, but bases feel slippery. So an example of a base is soap, and the base is what gives it that slippery feeling. Now, both acids and bases are strong electrolytes. And so this means that they are good conductors of electricity. This is because they are ionic compounds, and when they dissociate in water, they can conduct the extra flow of electrons through their solution. This also means that the light bulb in a conductivity meter is going to turn on in an acid or a base. So that's a good way, not of really telling that it's specifically an acid or a base, because any ionic compound will do that, but it is just something to note that they're both good conductors. One other way that you can but tell if something is an acid or a base is how it behaves with metals. So acids are going to react with metal. When you put a little bit on there, it will start to smoke and bubble and things of that nature. But when you put bases on there, they do not react with metal. And so one tricky thing about acids and bases are when they're in their liquid solution, they're oftentimes all clear. And so if you have two clear liquids and you're not sure what they are and you're trying to characterize them, if one reacts with metal and the other does not react with metal, then you know that at least that characteristics, which it looks like I said, my grammar as I'm like talking while writing something different is not so great. So bases I had it right the first time. Bases do not react with metal. Pardon my grammar mistake there. We all know that I'm a science teacher, not language arts, for a very good reason, though I try. Another way to tell acids and bases apart is by their pH, which we learned about in our previous video. An acid is going to have a pH that is less than 7, while bases are going to have a pH that is greater than 7. And you can't determine a pH without doing like a test. You can't just like look at it and know the pH. And so we'll go over some ways to do that. Now, when we talk about household examples, some household examples of acids are lemon juice, vinegar, let's see, anything with like sour candies. The part that makes them sour is citric acid. Your stomach acid is hydrochloric acid, and it's great for digesting your food and breaking it down. Battery acid is found in the battery of your cars and in like regular AA and AAA batteries, which is why if you've ever seen a battery that's like really old kind of explode, that's because acids and bases are both considered corrosive, meaning that they eat away at things, especially the acids when they're in metal. So eventually old batteries kind of explode and do that. Bases, some household examples are soap, bleach, Windex, really any kind of cleaner, ammonia, lye, which is not saying like you're a liar, but lye, which is used in soaps. Baking soda, really anything used to clean is going to have a base in it. Your shampoo to clean your hair, all of that. Now, we mentioned like, okay, what are some tests we can actually perform to determine if something is going to be an acid or a base? And one thing that we can do is we can use an indicator. So typically when doing a chemical experiment, we would use an indicator, which is a chemical that is going to change color at specific pHs. And so two that you really need to know are phenolphthalein, which, yes, that is a complicated word to spell, but it's phenolphthalein. The pH makes kind of an F sound. And the other one you need to know is the universal indicator. Now, the universal indicator is called the universal indicator not because it's one magical indicator that does it all, but because it's a mixture of regular indicators that make it change colors multiple times. So phenolphthalein, though, is only going to change colors. It's only either one of two colors. So phenolphthalein is clear when it is in an acid, and it is a pinkish purple color when it is in a base, which is why when we do experiments, we typically add the phenolphthalein to the acid and slowly add a base, trying to get the palest of pinks, because phenolphthalein turns pink at around a pH of 8. So if you get it barely pink, that means you're probably right about neutral at 7. Whereas the universal indicator is going to change colors multiple times because it has multiple indicators in that solution. So at a pH of 1 to 3, at a pH of 1 to 3, the solution is going to be red. Whereas from 3 to 6, it's going to change to be kind of like an orange yellow color. And at a pH of 7, it's green. We like to say, you know, green is good, like green means go, that sort of thing. And so if your pH is 7 and your pH paper or your indicator is green, then that typically means it's not going to harm you, at least not in the way a strong acid or strong base could. And from 8 to 11, it's going to be blue. And then from 11 to 14, it's going to be like a violet purple color, kind of indigo, so it gets just darker and darker and darker. And so that's the universal indicator. Now, pH paper is a second way of doing it. We often use this in high school, and if we were in class, you would 100% be testing a lot of different things with the pH paper in our classroom. But this pH paper changes colors just the way indicators do based on the pH. And so you can see if we like kind of zoom in on this picture here that this green, that's neutral. So that's about a pH of 7, meaning that's not really an acid or a base. But this dark purple color here, that one's going to be about a pH of 14, and this red one is going to be about a pH of 1. And typically when you have pH, they give you a scale to kind of compare it to so that you know what you're testing against. Now, the third way to tell is with litmus paper. This isn't as commonly used because it's not, in my opinion, as super helpful, because all it can do is can confirm if it's an acid or a base. It can't tell you anything more specific than that. So litmus paper has two types. There's red litmus paper and there is blue litmus paper. Now, red litmus paper, when it's dipped into an acid, stays red, whereas red litmus paper, when it's dipped into a base, turns blue. And one way I remember that base and blue go together is base starts with the letter B, and so does blue. So always keep that in mind. Whereas blue litmus paper, when it's tipped into an acid, will turn the red color that red litmus paper stays, and blue litmus paper dipped into a base stays blue. So they are at least consistent in that way. And so these are 3 ways that you can determine if something is going to be an acid or a base, and some overall characteristics of acids and bases.